as I mentioned earlier, it is definitely bedtime, but we'll see how we go. So Tara and the guys asked me to do a review of marine species distributions in changes in Australia, but I thought I'd start off with a couple of slides on how we came to have so much research investment in examining range shifts in my part of the world. Because I'm first up, I've got a few general slides around or really making some comments about range shifts, and then I'll go into a review of the Australian case. So as was mentioned earlier, actually, east coast of Tasmania, which is just here, is definitely a hotspot for climate change. So we're in the top 10% for rates of warming, those dark orange places there on the map. And it's warming so much because we have that East Australian current, which is not coming through on that, but that doesn't matter. Okay, so the East Australian current is pushing much faster and stronger into the coast of Tasmania. So it's a seasonal current, pushes down in summer, retreats in winter, but we literally have this change in current system. And we also have in Tasmania a lot of recreational fishing. We produce the highest value of seafood nationally, which is pitifully small by international standards, but that's what Tasmania produces. We've got lots of diverse communities of temperate marine life, and so we've got a high rate of temperature change, and marine systems are really important to Tasmania. We also noticed quite early on some range expansions of some species that were having quite substantial impacts. The key one there is the sea urchin, so that was moving into Tasmanian waters and creating urchin barrens. We've got new octopus species, that's 13% of an octopus fishery now. It was only detected a couple of years ago. A whole lot of intertidal species that have moved further south, dozens of fish species that have changed distribution, and a whole lot of foundational changes or changes in the habitat species as well. So high rate of warming, lots of changes in our marine systems. And when you put it together, pre-warming and then looking at the warming situation, it actually looks like a very different system. So I've been diving off our east coast of Tasmania for around 25 years now, and it looks entirely different to what it did a decade or two ago. So very visible, in your face kind of changes. And so we've got a large focus on range shifting species in southeast Australia, and that comprises observational, modelling and experimental work as well. And the experimental work that we've got going on, and this is just in my lab, so there's a lot of other work going on as well. We're looking at metabolic scope, aerobic scope, costs of swimming, attack and escape speeds, a lot of competition experiments and behavioural choice experiments as well. And these are all undertaken on range shifting species as they're coming into Tasmania. So we're really trying to have quite a holistic look at what kinds of animals are moving in and what we expect there to be in terms of changes in the near future. So if we look at range shifts globally, we know that they're moving around 17 kilometres per decade on land, around 72 kilometres in the ocean, so much faster responses in the ocean, as mentioned earlier, also moving deeper. And obviously there's many other responses to climate change as we've just been talking about, but one of the reasons why I like looking at range shifts is in many ways I think they're a net or an integrator of all these other responses that we have to climate change. So ultimately species thrive in a location or they don't, and obviously we've got those shifts occurring greatest where the climate has warmed the most. Now this graph here shows from each study, so there's a Dolby one mentioned earlier, Perry et al., the percentage of species that have been recorded shifting in each of those studies. So each one of those studies is either a study where they've looked at a whole range of taxa in a given region or all the species in a region. And between 25 to 85% of species are already shifting, so pretty high rates of animals already moving. Obviously we have lots of variation in the timing and the pace of these movements, and I think that's what actually makes them incredibly interesting puzzles to try and understand. But when we take a look at what how to explain some of that variation in the rates and magnitudes of shifts, as has been talked about earlier, the methods are really critically important. So this paper by Chris Brown from Queensland in Australia was able to show that 22% of the variation in range shift rates could be explained by the method that you use to detect them. So I think that's something that's very critically important. We know from Jorge Garcia Molinos's work that around 40% of that variation is explained by the climate velocity, so that movement of the temperature isotherm in space. Jennifer Sunday, when she came to work in our lab a couple of years ago, was looking at species traits. And when you combine climate velocity and species traits, that's around 50%, 57% of the variation. And the traits that were most influential was latitudinal size range, so species like these two here, yellowtail kingfish and southern Maori wrasse that have got a very wide latitudinal distribution and moving faster, and then species that were of a lower trophic level. But I guess different studies around the world that have been looking at traits have found different traits have been influential or not, but for our case in Southeast Australia, definitely those. And then when you look at some more work from Jorge Garcia Molinos again, when he looked at the agreement between the current direction and the movement of the temperature isotherm, that explained an even higher percentage of the variation. So we are starting, I think, to get a little bit of a handle on what underlies some of this variation in the rate and the magnitude of shifts. But of course, we're not looking at ecological interactions in a general sense. Some studies are looking at species interactions in a pairwise kind of way. Habitat availability is obviously really important. And I think this one here, the stage of the shift being measured. We often talk about range shifts as if it's a binary response, something has shifted or it hasn't, but it's actually a process that occurs over a much longer period of time. So we talk about it like it was absent and now it's a consistent population, but really that happens over a series of stages over time. And I think we're possibly measuring different parts of that process rather than thinking about it in that continuous kind of way. The other thing is that I think we're very species focused, and that sounds like a strange thing to say, but I think we're constantly talking about what's the local climate velocity or the life history traits or some of the direct interactions of the species that are shifting. We don't actually think much about the receptiveness of the communities that species are moving into. And there's a whole lot of properties in that receiving ecosystem that might be very important in terms of whether they're facilitating or hindering shifts. So if you think about it, a range shift is really a function of how shifty a species is and how receptive the community is. And you might have a species, for example, that is very shifty and it could move into an environment that had a very low receptiveness. Or you might have another species that was not very shifty, but it could move into an environment that was really receptive to new species. And I think there's a lot of parallels there with other research fields. So, we're thinking about range shifts, but invasion ecology, they have been thinking about invasion processes in both those contexts for a very long period of time. So if you're looking at an invasive species, you wouldn't think about it only from the context of that species. You would think about it in the context of the characteristics of that receiving environment. And then there's parallels there too with disease, so an infectious agent and a host. You don't think about disease just in one of those things on its own. So I think at the moment with range shifts, we're just thinking about one of those axes. Some of the ecological consequences, as we know, can be pretty large. One example here is Centra stephanus, that urchin that's been moving down the east coast of Australia, moves into our reef areas and creates those rocky urchin barrens. We do have large lobsters that can eat the urchins, but they're fished out. So if we have large lobsters, then our urchin barren problem is reduced. But the issue is we've had around $10 to $15 million, which is a lot for Australian research, spent on this kelp urchin barren problem. But we have a whole lot of new species moving into that system that haven't even been thought of in this context. So we've got that new octopus that I mentioned moving into that area. We know that octopus will eat lobster, and they'll eat abalone and other critical species in that system, but we haven't even thought about how this whole suite of new species coming in might affect that problem. So the potential role of other species hasn't been considered there. And we know through a qualitative modelling study, so that's loop analysis, looking at the interactions between all of these species, that the octopus is actually a potential backup buddy for the urchin. So if we've got octopus in that system, we have other new species as well, snapper, but if the octopus is playing a large role in that system, it can actually be reinforcing the role of the urchin because it eats the larger lobsters. So my point there is, in terms of impacts, we are thinking of those in a very single species way, but I think when we're trying to take a more ecosystem approach, obviously it's better to look at the range of species moving into areas and what kind of implications they might have. But we know that changes in distribution matter for ecosystem structure and function, like I've just mentioned, food security, human health, livelihoods, feedbacks to the climate system, and culture as well. And when we take a look globally, this study here from 2017 just shows a handful of some of those changes in distribution that have already had very significant impacts either for human well-being or for ecosystems or for governance challenges. So lots of shifts all around the world. There's only a handful of them, as we know, but very significant challenges, I think, for society. So if we have a look in detail at what's been happening around Australia, I got one of a student to do a systematic review of the range shifts that have been detected around Australia specifically for this study here. So we looked at a whole range of keywords related to range shifts in Australia. Of all the papers that were returned, around 11% of those did actually contain information on range shifts. And there's been 48 papers since 2003, and these are just different parts of Australia. And so you can see that there's been a reasonable amount of research effort around the country on these range shifts. When we take a look at those suite of papers and the kinds of environmental drivers that were discussed in those, this paper here by Thomas Wernberg had a very nice summary diagram talking about those global drivers. Has this got a pointer? No. Talking about global drivers of change, the regional ones, and then very local drivers as well, and the complexity of those as you're looking across scales. Obviously, sea surface temperature was the main driver that was talked about in these papers, but also the changes in the current systems that I mentioned earlier. So this is the Lewin current that's strengthening, and the East Australian current as well. And also a lot of discussion about marine heat waves and ENSO events. So we've had marine heat waves on both the southwest and the southeast parts of the country, and they were, I think, up to around 4 degrees warmer than usual for a period of months. And what some of these studies have found is that those heat wave events really facilitated establishment of some species that have since persisted after that heat wave event. So in terms of spatial differences, this graph here shows the numbers of species shifting per region. So there's almost 90 species in Tasmania, and this is all marine species, by the way, not just commercial species. In Western Australia, the grey there's around 43. So quite substantial, oops, I haven't changed the number there, bad me. So quite substantial numbers of shifts all around the country there. In Tasmania, that's the orange, most of those are range extensions, so 88% of those changes are range extensions. In Eastern Australia, that's the blue, we're seeing 23% of those range changes are range contractions. And in Western Australia, in the grey there was a focus on the heat wave and how that had really had a big impact. And most of the changes in Western Australia are in Perth, which is just here. So I think that's a function of geography where most of the research has taken place. There's very patchy data, as we were talking about before, and I think Australia is a very data poor system in general for a Western country. But what we found was that there was more historic data available for the temperate species. So in the temperate part of the world, it's not quite as data poor. Tropical species are very underrepresented, and there's possibly a dependence on habitat. So the coral is a hard limit, if you like, for some of these species. But most of these species that we detected to be shifting were of temperate origin. Obviously, that's because species are moving into the temperate further south for us, and quite a lot of tropical species as well, but mainly temperate species that are shifting. When we look at the types of species, out of the 195 species that we detected shifting range since 2003, most of those were fish, algae and invertebrates, with just a few of the coral species shifting. In terms of, there's different data sources underpinning the detection of these shifts in the different groups. So fish, it was mainly citizen science, historical surveys and commercial catch data, not surprisingly. For the algae, it was herbarium, historic data, and invertebrates, historic survey baselines as well. So when we look at some of those general trends, I think the fact that we're getting more range shifts detected in the southeast is probably a reflection of research effort. So this is a different literature review, just looking at the research effort on climate change in general in each of these regions, and most of that does take place in southeast Australia. So it's a bit chicken and egg. We're not sure, are these patterns genuine, or are they a reflection of the research effort? There was a definite lack of observations of range extensions in the tropics, and that is potentially a lack of research effort and a lack of coral habitat shifting further south as well. And just a comment there that some of our species are quite cryptic or boom and bust, and it's much more difficult obviously to try and detect trends in those kinds of species. In terms of the types of shifts that we were recording, so this is the total number of species observed shifting, and then whether they were poleward or equatorward extensions and contractions. The ones with the star are the ones that were consistent with what you'd expect, the logical issue with the climate velocity. So most of them were poleward expansions. Much to my surprise, there was actually a number of poleward contractions recorded as well. And for me, that was a bit of an eye-opener, because I work mainly on the extending end of things, so it was a good reminder that actually things are contracting as well. So there was over 40 species that have got the poleward contractions recorded as well. But a couple of responses in the opposite directions to what you would expect. So potentially they could be things like predator release or issues of detection probably as well. So we would suggest that there's probably significant bias, because a lot of these studies are only measuring the poleward extending edge as well. They're not often measuring the top end of the distributions. In terms of the data sources, because that was something that I think we've got on our agenda to talk about at some point, most of these data sets are from visual surveys. So this is the dark orange, and this hasn't come up very good here, but the dark orange bars there. So that's where most of our data is coming from. Visual surveys were by far the most common, and then historic data sets as well. I just wanted to say that I think that understanding these species redistributions in a holistic way, I think could be benefited by citizen science, as we've seen in the US and in Australia as well. So in Australia, we thought, we've got 60,000 kilometres of coastline, how do we detect some of these changes? But we have a large percentage of the population, 30% in some regions, that are fishing and diving. So we started a project called the Range Extension Database and Mapping Project, which is specifically to detect these species as they are shifting. So fishers and divers send in out-of-range observations. We only take photographic observations. Each one of those is verified by a team of scientists around the country. We have 80 scientists in that verification team. But with those out-of-range observations, it's a very fair question, are they range-shifting species, or are they vagrants? So we had another study by Hannah Fogarty, so it's a different Fogarty to the Pinsky papers, and she worked with Elvira Polchanska and Michael Burrows trying to understand what did these out-of-range observations mean. So are these first sightings essentially influential or informative, sorry is the word I'm after. And so she looked at a global data set of out-of-range observations. She considered the influence of sampling effort, and as her measure of sampling effort she used the OBIS data. And she compared the observed versus expected frequency of out-of-range observations in different climate trajectory regions. So she used the data set from the Mike Burrows paper of the different climate trajectory regions and then looked at those out-of-range observations. So I was very interested in this study because she's essentially testing the relevance of that REDMAP data from that citizen science program that we've been collecting all around the country. And she found that those out-of-range observations are associated with longer-term climate features. So they're not one-off random occurrences or vagrants, but they're actually associated with particular climate features. And so I threw this in because I think it's potentially interesting for us thinking about how some of these range shifts take place. So we're getting more out-of-range sightings in those fast-moving climate trajectory regions and the climate sinks. And those climate sinks are where those isotherms locally disappear. And so she's getting out-of-range sightings that are 8 times more likely than you'd expect compared to random in those sink regions. And the sampling effort did not explain the occurrence of those out-of-range sightings at all. So I think there's potential there to use some of these types of programs to get an early indication of what kinds of species are starting to shift and move in different areas. So in terms of, so that's how we're, I guess with the citizen science data, trying to get an early indication of what species are shifting. There are also some modelling efforts on projection around the country, which I'm not going into, other than to say for our projected shifts, obviously with most of the studies that have been undertaken, it's temperature that is the main factor there that's important, and it's mainly fisheries species that work has been undertaken on. But that warming water, in addition to just changing distributions, it's obviously also very important for breeding and spawning seasons, migration timing, ontogenic changes, and for us in Australia, increased stinger seasons. So we have a lot of things that can hurt you in the water, and they're changing distribution. So there's a lot of interest in this climate work in the community and local councils because of that reason. And I think the next slide talks about crocodiles. So we've also had crocodiles occurring much further south, like hundreds of kilometres further south than you'd expect, and tiger sharks as well. So we've already had tiger sharks observed in Tasmania, which is very out of range. So there's a lot of interest in various sectors of the community around trying to get a better understanding of some of these range shifts, because we have a large number of things that can hurt us or rip us in half, as the example of the shark there. Some of our projections as well have been on the foundational species, so the algal and seagrass communities, and there's a lot of projections saying that there will be very significant changes in some of these habitat forming species that are supporting our commercial and our recreational fisheries. And also, obviously we have species as well like dugong and turtles that are very dependent on some of those habitats as well. But some very significant changes predicted in some of those algal and seagrass species. And that was all that I had. Thanks.
Great. So, questions then for Australia, man, what's going on?
Yeah, the question. I have actually 2 questions. The first one is, I suppose, short. So these changes in the fish distribution, have you seen that there's also change in primary production, secondary production, or maybe benthic production that is either following or ahead of these distributional shifts?
That's a very good question, and I don't think anyone's actually looked at the link, but I know we have had changes in productivity and that there's some pretty large declines, I think, in productivity predicted for most parts of our coast, because we don't have a lot of upwelling, for example, around most of the Australian coastline. But But that would be a very interesting thing to look at.
And the second one is about these early indicators for range shifts. And the paper also looked at population expansions not related to temperature. Because at least in the Atlantic, with the mackerel case, you have a huge range expansion also to the north, just large populations searching for food.
Yeah. No, we haven't. Oh, well, I guess for each study that takes place, we're trying to look at multiple stresses and other explanations, but I don't think there's been any formal sort of investigation. No. But obviously you try and make sure that you're using the right explanatory factors. But I guess that's why we have a lot of the lab work underway. So we're trying to come at the issue from a mechanistic approach as well, not just an observational one.
I was going to ask about the management. Other than the crocodiles and sharks, you didn't talk that much about
That's because I do that tomorrow.
Oh, okay. Because I guess in Australia you're not as limited by cross-country boundaries as much as.
We do have state-based jurisdictions, but I think the bar is a lot lower for the states. So there's very high cooperation. For a large number of the species where there are stock assessments, they are multi-jurisdictional stock assessments, and so a lot of the surveys are as well.
What did you think about Bjarte's idea that they're chasing feeding opportunities, that's a driver for redistribution?
For some species?
Yeah.
Oh, absolutely. I think that would be.
And is there sort of evidence? Can you make those sort of trophic connections?
Not really, but I think in terms, food availability would be a big driver for a lot of species.
Yeah.
But, again,
it's kind of like a Matryoshka doll, that some things chase temperature, others chase food that's chasing the temperature,
Yeah, I think it depends a little on which latitude you are at also. I mean, there's no ice around Australia to take it that way. I mean, in the Arctic it would, the seasonal factor is so much bigger that they would go and chase food in the summer in a very different different way.
The Sunday Attell paper did show that generalist species are moving quicker. So I think that maybe species that don't have such strict, predator-prey requirements or dietary requirements are able just to follow their temperature preferences more easily because they don't have a strong dependence on a particular species.
That makes sense.
So have the results you've shown today, has that motivated more interest in new surveys? Or better surveys? Has it motivated interest in better surveys?
Oh, absolutely, yeah. But we have a hill time trying to get funding for proper surveys. So Reef Life Survey is probably, I reckon most of that orange bar that was the survey data, and that's a volunteer survey program. But other than that, we don't have a lot of funding for surveys, and there's probably not a lot of stock assessment surveys either for most of the species. There are for rock lobster and for abalone, and for some of our Commonwealth species, but it's not common to have them.
Quick question too. You have your data is impressive, and I guess, do you feel as though the lack of data is at the ichthyoplankton level? Are you getting pretty synoptic sampling of how the ichthyoplankton is being, distributed with the strengthening of current systems and stuff like that?
I don't work in that area.
Okay.
But there's certainly people that we could ask.
Yeah.
But generally speaking, our monitoring is very crap.
Yeah. The other question I had was the idea of generalists being sort of the movers more than any other species or groups of species. Are you collecting food habits that could show you there's been a change in the scope of their prey source, and that might kind of help to show what are vagrants and what are more...
We have it as something that probably could be done, but no, it's not something that we've done so far. One of the things that I've been wondering about is some of our very large ships, and that would be things like yellowtail kingfish and snapper. Is that like, they're both species where even though they're commercially fished and very heavily recreationally fished, there are no surveys and there are no estimates of abundance. But there are anecdotal reports that in the centre of their abundance, they've increased in abundance. So I'm wondering is for those species that seem to have made really rapid, sudden, big shifts, is that a case of, we've always had 0.001% of the population and that 0.00 whatever percent just happens to be much bigger now, and that's why it looks like a very sudden range shift. I think that's McCall's hypothesis or something, isn't it? So I think in a lot of these changes in distribution, it would be very useful to be able to have measures of abundance throughout the range, which we just do not have for most of the species.
Yeah, I have a question about the concept of receptiveness that you brought up. I thought that was super interesting, and the parallels between invasion ecology and disease ecology. And I'm wondering, basically, what do we know about what makes a community receptive to new species coming in?
Yeah, I think that has to do with network stability, but again, not my area. But what I started thinking about that was invasion ecology. If you look at invasion ecology, they've got, I don't know, however many different theories of, how and why invasive species are successful. And about half of those have to do with the receptiveness of the environment in some way, and the other half have to do with the characteristics of the species. But if you look at the history of invasion ecology, they were all about the species at the start, and then that was kind of like, maybe it's the characteristics of the environment as well. And now you just wouldn't think about them separately, but that's exactly what we're all doing, I think, in terms of range shifting species. And it's a little bit different because you've got the, it's a continuous distribution rather than a, species flying in from somewhere else and not in a continuous way. But I think there's certainly a lot that we could probably learn by looking at invasion ecology and how they approach this issue, and some of the factors that are shown to be really important in invasion ecology might be useful for us to have a look at.
I just have one more question that might be relevant to tomorrow as well as, relevant to what you just talked about is when you're looking at, spatial distributions and shifting populations, number one, is the tools you're using quite quantitative in their ability to monitor or detect, an effect in that change? And secondly, is there any way you can assign an error to those different events? In other words, species A shifted this much and this is the error. Species B shifted this much and this is the error, because eventually when you do a meta-analysis, you're going to have to not assume that everything is equal.
I think that would be very good to do, and we would probably be able to do that for some species in a quantitative way, and then perhaps some qualitative kind of quality criteria for others. And that's actually something that we were talking about trying to do for this analysis, was come up with a list of criteria around how robust do we think each of those assessments would be. But there's certainly a very big difference. So some of those inshore reef changes are much more reliable because we've got the Reef Life Survey data going back, I think, 20 years now, which is not a lot of time, but it's quite comprehensive data over that critical period where we were expecting to see significant changes. And then other ones are simply herbarium records that would have probably a large amount of error around some of those estimates, for sure.
Okay, so final question at this end.
Maybe other people do, but I mostly think about fish, so I thought it was really interesting. You had some invertebrate and a lot less mobile examples, and you mentioned the interplay of currents and temperature. So I was wondering if you think, from your experience working on less mobile species, what we can learn about how much of these range shifts are driven by dispersal of kind of larval particles versus actual swimming.
I think both are probably important. But we've had very large shifts in things that are not swimmers. So clearly, I think they're, dispersal playing a large role in at least some of those.
Okay, so John and Asta in Australia, any comments on Greta's presentation of what's going on down under?
heard it all before.
John's turned his mute off.
I mean, it's never kind of for credit talk like.
Okay, Asta, are you there?
Yes, I'm still here, I heard it. So, I think it's so, I don't really have specific comments at the moment.
Okay.
Agree with all of that.
Okay, well, it's nice just to know you're still awake.
But just while we're talking about it, you mentioned the quality. I would love to get some ideas from this group on how would you assign, a level of quality to documented range shifts, because that's what we want to try and apply to ours. So I'd be
Yeah, getting into the nuts and bolts of how you're actually handling your data and what could be done with what you've got would be interesting, because even, you're defining range presumably on some treatment of presence absence. The sort of approach to the data, which is...
Actually, we have got one study where we did try and do a level of confidence, but that was using qualitative data itself. Yeah. So we had two decision trees, one where we said how certain are we of the range boundary in the first place, and we flowed through the decision tree to arrive at a level of confidence of the original range boundary, and then the additional out of range sightings that we've got, and were there any issues of species being cryptic or any issues of detectability and all that kind of stuff, and then we put those two trees together to arrive at a level of confidence that something is undertaking a range extension.
Yeah, some people use like Delphi or some expert elicitation process.
Yeah.
Okay, final word to Paul.
Oh, just, so Jim Thorson will be joining us later this week remotely. I think he's got a paper out, one of his like 80 papers he does a year, where he's very interested in spatial modeling. And I think he's developed some methods to sort of extrapolate a range shift. When you have an area that is shifting to that has the data. It's almost kind of like extrapolating from an area where you have a high survey density to an area where you have a survey density.
Okay. So, and that's something that is working on at the moment?
Yeah, I think it just came out this year.
I'm going to ask you for that.
Okay, I'll have myself, I don't read it.
Well, okay, read all those papers.
But he's using mostly quantitative data for that.
Yeah, but I was thinking of you mentioned that you might have cases where like one part of the range is sampled more intensely than another part of the range.
Yeah, absolutely. Yeah, we definitely have some stocks where some states will survey them and others won't.
Mm-hmm.
Yeah.
So all of his code is available on GitHub.
Okay.
If you look under FAST,